Has any one of you already worked with Great Expectations? Just out of curiosity? Not too many, that's good. So it won't be too boring for the rest of you. Yeah, today I wanted to share my experience with this library. I recently discovered this library like 1 year ago. It's a library for data test. And consequently also what's related to creating data testing, so data profiling and how to automate the creation of these tests. I just want to create some context because I'm the co-founder of a startup working in the synthetic data field. We offer synthetic data generation services. Synthetic data is artificially generated data, which is generated to look realistic with respect to a use case. So the objective for this data is to be used in situations like software testing or data sharing, creation of data sandboxes. It's artificially generated, so it's not sensitive data, but it should result realistic. So if the synthetic data doesn't look like the real data, there's no use of it. So this is why I recently discovered the concept of data testing, because for us, testing synthetic data is a way to determine how realistic it is with respect to an original data source. The idea in our application is that we have an original data set. We can create some tests that measure the properties of this data, and we can apply the same test to a synthetic data set. But what I'm going to tell you today doesn't apply strictly to synthetic data. It can be applied to any kind of data quality application. It's just to give you some context. But what does it mean to test data? We are maybe familiar with the concept of unit testing for software. The same analogies can be applied to data as well. So we can think of creating some unit tests to understand if there's something wrong about our data, some inconsistencies, some errors, some incongruencies. The idea, if we talk about testing, is to make it programmatically. So to create a way to automatically check whether data passes or not some tests. And this is a way to also be able to measure data quality. But instead of explaining what data tests are, I will show you directly because maybe it's easier to understand. Let's, for example, take a table containing some orders from an online shop. It's a table containing numbers, categories, date times, text, all types of data. If, as a data owner, we look at this table, we might understand that there are some rules that this data should comply to. For example, if you look at the quantity of product order and the price of product, there should be some statistical relations, maybe relating the fact that a product which is cheaper might be bought in larger quantities. If a product is very expensive, it could be very unrealistic if it's bought in large quantities, for example. Or if we look at the datum columns, we might immediately see that there are some relationships between the fact that an order date should always be before a shipment date or a requirement date. These are some rules that we, by looking at the table, we understand and we want to implement programmatically. Another rule could be like maybe there are some missing fields. Maybe they make sense because maybe a missing field is missing because, for example, in this case, the order is being processed, so that field is not yet been filled. So it's acceptable to have missing values. In other situations, missing values are a problem. But in this one, if we identify this rule and we write it down, we can measure data quality from this point of view. So the idea of Great Expectations is to provide a way to perform this kind of measurements by providing a library. It's a Python library. It's an open source library developed by an American scale-up to programmatically write data tests, unit tests for data. It's a Python library. It's open source, and it uses a very expressive mini language to allow users to create this test, and I will show you some examples later on. And this test, the objective of this library is to be able to monitor data quality. So we write a test suite. We apply it to our data, and by measuring how many tests are passed or failed, we can measure how data quality changes in time, for example. This library is compatible with most of the data manipulation, most common data manipulation frameworks like pandas or Spark. But at the core of this library, that's a definition of expectation. An expectation is a declarative statement that describes a property of the data. This property is very important because it should be verifiable. So we should be able, taking this property, to go to a batch of data, understand if this property is passed or not. So in this case, this property is, the mini language is this one you see on this side. This expectation refers to a column called room temperature. And the expectations define that it's very simple, that the value should be between 60 and 75 Fahrenheit, for example, within a certain confidence. The idea of the mode of great expectation is also tester docs and doxer tests, because once you are able to write these expectations programmatically using this mini language, the same expectations becomes a documentation for the data. So it can be automatically translated to documentation that you can use to enrich your data. But I wanted to show you a more real example by going through a very short notebook. So this library can be installed via pip. It's a Python library. The first thing that you have to do when starting using this library is to create a suite, to create a project, basically, where a directory where you serialize all your information about your data. And you can do that by using this great expectations init from command line. And then you can create this data context. So this is our project. Everything we'll define about our data will be included in this context. The next thing is, since we are talking expectations that should be verifiable, we need to provide a sort of batch of data that can be used to verify these expectations. So as I said, we can use pandas, for example, and in this case, we are importing a pandas data frame inside this suite by creating this batch, which creates a wrapper around our data frame. This particular example is a tabular data set containing numerical and nominal categories referring to some insurance claims. It's not really important to this very particular example, but it's basically insurance claims filed over months, and it's used for a fraud detection use case in machine learning. But the important thing is that there are columns maybe describing individuals who applied for an insurance claim. We defined this batch, we imported it in Great Expectations, and we can start adding expectations, which is the most important part. We can do it manually by using these expectations. There's a catalog of expectations you can find on the website that defines a number of tests which are usually performed. For example, column values between is very reasonable test. You can find it in this catalog. There's a test that it's not there in the catalog. You can write it yourself. So they provide some template to create a new test based on your very particular needs. In this case, we are creating expectations for the column week of month. It's a column that goes between 1 and 5. And we know that a week of month cannot be 6. So that would be a problem in our data. So we create these expectations, expect column values between 1 and 5 for column week of month. Once we run this expectation, the tool immediately verifies it on the batch of data that you provided. So in this case, it says that no exception that was raised. All the elements successfully passed this expectation, which is good. And so we can continue adding expectations. All this is done manually. For example, we can create another expectations about a column age. The minimum should be between 16 and 20. The maximum should be between 18 and 19. And we can keep adding expectations. There's also a probability component to it. We can add it using this argument mostly. We can say, okay, this column should have this kind of expectation, but I allow for some wiggle room. I don't expect the data to be 100% accurate all the time, or maybe it's a statistical quantity. So I expect this range within a certain probability, and we can use this mostly. In this case, this returns how many rows in the batch dataset used to validate it have passed or failed. The interesting part here is that by checking this expectation, we saw that there's some partially unexpected list, which didn't raise the trigger because we defined this 90% acceptance ratio. But there are some columns, some rows that have age 0, which is identified by this check. It might be a problem that we might want to check later on. Another way to create a very useful expectations is using conditional expectations. So we can define expectations for a column. So we take the column age. We expect the values of the column to be between 25 and 80, but we put a condition. So only take the rows that correspond to this pandas condition. There are a few ways to create this kind of parsing. In this case, we are using pandas. So we define a row condition, check all the rows where the column marital status is equal to married, and create an expectation about the column age. In this case, we are saying that maybe married people are a bit older than average. We are saying that if the individual is married, maybe the age should be between 25 and 80, not 18 and 80. In this case, it's also a probabilistic expectation. It depends on another condition. It returns some unexpected count, of course, and you can check what are these unexpected counts. So in this case, it found that there are a few individuals which are very young, maybe 18, 19, who are married, which is acceptable, but in terms of data quality, it's a measure that we want to monitor for our metrics. There's also, once we are happy with our expectations, now I introduced only a few, so it's a bit useless at this state, but once we collected enough expectations, we can create this suit, which is the one that will be used for test. And this suit is serialized as a JSON. So once here I created only a few expectations, they've been serialized using this JSON that can be integrated with a data orchestration platform, for example. The idea is to be as flexible as possible to be integrated with existing infrastructures. Once we have this suit, the interesting part is what I was talking about, the data documentations, because since these expectations are very semantically meaningful, we can automatically generate some data docs based on these expectations. And there's a function in the create expectations that converts this JSON into a documentation. So we can check for our project an HTML browsable document that lists all the expectations that we defined so far. It's a bit empty because I didn't include too many expectations, but it's a useful artifact to put together with our data, because it defines what are the quality metrics that you want to adhere to for our data. And this is very easy to do because these expectations are quite meaningful. So it's just a matter of converting it in another format. The idea is that once we have this expectation suit running, we can apply it to new data batches, because it's the most important thing. We have a test suite for our data. We have new data coming in, and we want to measure if this new data abides to the same quality constraints that we created, and we can use it. We can do it using this validate function. So here we load a new data batch. We create a timestamp just for us to have some kind of lineage about what's happening, and we can apply this suit to a new data batch that will return results. So it will tell you how many of these expectations failed, what are the statistics about the acceptance or the rejection in terms of what you define. So since these are probabilistics, they will also tell you, even though the test passed, the test failed, some of the test partially failed because of some rows. For example, here identified an age row corresponding to a number 9999, which is a problem. Didn't make the suit fail, but it's something that can be reported and can be tracked. And this is all very interesting. I really like this library because it's really easy to implement. They have a great catalog, and you can also write new expectations if you don't find the expectations you need in your catalog. The challenging part is that, for example, now I was adding expectation by hand. If you have a big data set, if you have a lot of tables, if you have a lot of expectations to define, it can become a problem. So it's really difficult to define this data test by hand. The idea is like, can we automate this process of creating data tests? And that's the concept of data profiling. So try to find a way to generate this kind of expectations as automatically as possible. Fortunately, with 100% accuracy, it's impossible, because it's possible to completely understand the semantics of a data set without a data expert. But it's something I wanted to share with you today, because we are working on a library to create this kind of profiling. So we are working on an open source library, which is a very work in progress, which aims to, at creating these expectations as automatically as possible, given a table, create this kind of data docs and expectations, especially focusing on the relationship part. So on the relationship between columns and rows of this table. We do it using very heuristic approaches. The idea is like it should be something that works fine enough to create some kind of base that then can be integrated using expert opinion. But what it does internally is like it uses, for example, machine learning to understand if there are deterministic rules between columns. Like if there's a column which is the sum of 2 or 3 more columns, that can be detected using a machine learning approach by predicting a column using the rest of the columns. Or we can systematically analyze the conditional probabilities of our data by checking how this a posteriori probability changes by changing some raw conditions from the expectations I was showing you before. And this is it's an ongoing effort, and we are always happy to look for contributors because it's a very challenging task. But we created this library that allows for this profiling. So I can import a table where you can specify maybe the presence of a primary key, or presence, if you're talking about machine learning, of a target key. This profiler, first of all, tries to understand the entities contained in this table. If there's the nominal labels rather than numbers, rather than the datetimes, they should be understood properly even before doing this profiling. But once this knowledge is there, what it does is start applying these heuristic checks. So analyzing the distributions between columns, analyzing the presence of deterministic rules, and in general the relationship aspects of our data set. And it produces an output which is, for example, a description column by column of the content, like the statistical distributions, the presence of missing values, what's an acceptable level, for example, of missing values in a column. If I have a column, I can get from this kind of output. For example, if it's a categorical column, you might have using this profiling an idea about the presence of dirty labels, because here it's a column referring to vehicle manufacturers, and there are few typos, like there's a Nissan or a BMW, no, BMW is the right spelling, but using this kind of rare label detection, you can understand whether there are some mistyped labels, for example, in your data, and you can also, using great expectations, provide distributions about how much rare the label should be, for example, in your categorical columns. Or using this deterministic checks, using machine learning, you can, for example, here there's a column year, a column age, and a column year of birth. These columns are strongly related because the age depends on the year of birth and the year the claim was filed. And the profiler understood using a machine learning approach, so train a linear regression model, that this column is determined by 2 more columns. So this is an information you can use to package this kind of expectations. So once you have this kind of profiling output, you can generate these expectations, and this is done automatically. And this becomes also a documentation. So you can have this kind of HTML document generated using this kind of probabilistic and heuristic approaches that tells you how the data should look like. Like, for example, it identified that the year of birth is strongly related to the age of the driver. Or, for example, here we have a column which is a label which is a composite of a vehicle type and a policy type. In this case, we understood that another column, policy type, should be strongly deterministically related to the policy type, because this label is built by attaching two strings together from 2 different columns. And this is, as I said, valuable information because we are able to do it automatically. The idea is that once we have this kind of profiler, we can produce this documentation and allow the domain expert also to give a final check on this, because data profiling is really hard. It's impossible to expect that a profiler will understand everything about your data. But if we have a good enough success rate, we can do the fine-tuning of this profiling. And in my opinion, our opinion, Great Expectations is a great way to allow users to do this fine-tuning, because it's a very understandable and semantically meaningful library, and can allow for an easy check and improvement of this kind of profiling. And I think I said all. I still have 5 minutes. Oh, then we can go to lunch a bit earlier and skip the line if. Okay. Yeah, but I just iterate that it's a work in progress. We are always happy to look for contributors to our project, and if you want to hear more or talk more about it, please find me later on, and we can talk. Okay. Thank you.
Thank you. So we have some question for you.
We'll stand up.
Okay, better. When do you run the test of this expectation? When do you run the test of this expectation in your developer cycle? Use in CI/CD pipelines or
yeah,
stuff?
you can. Yeah, you can integrate it to very easily to CI/CD pipelines, or like for example GitHub Actions, or because the way it's written is really versatile. So it's I think it's very easy to put it in with any steps of a pipeline.
Okay, have you used it in a very large data set that don't fit into memory? If yes, what is your approach?
Yeah, I think so far our experience was limited to using the engine wrote on based on pandas, so that's not very scalable. They also support Spark, for example, and I think that will allow for better scaling up. But in our experience, we limited our application to pandas, not those two so big data sets.
Okay, so can it work also with non-tabular data, like example text, images, stuff like that?
I should check about it because it's a constantly evolving project. So I think they also aim to extend its application to other types of data, but I don't have experience with that. So.
Okay. Does the library include some automatic extraction of rules?
Yeah, the Great Expectations has I think they're also working on similar aspects about automatically defining, for example, ranges for each column. It's very limited to single columns, so it automatically extracts properties of single columns, but not relationships. So that's.
Okay. And what interact with the database data of the Great Expectation?
Sorry.
How does the Great Expectation interact with database data?
There are some connectors available. I think I don't remember the list, but they have a catalog of connectors for the most common, and there's a community behind it. So usually, if you raise an issue and ask for a specific connection to a specific database, they usually work it very quickly.
So thank you for your intervention. Thank you.
Yeah, thank you.